Hello, we are discussing about GATE 2011 ECE paper, and this question is related to electronics. In the circuit shown below, for the MOS transistors, mu n into COX is equal to 100 microampere per volt square, and the threshold voltage Vt is given as 1 volt. The voltage Vx at the source of upper transistor is, okay, mu n into COX is nothing but this value is going to be treated as K, and Vt is going to be given as 1 volt. W by L ratios are different for both transistors. For upper transistor, W by L ratio is 4. For lower transistor, W by L ratio is 1. So these both are going to be NMOS transistors. For NMOS transistors, drain will be at more positive voltage. So this will be drain of upper transistor and source of upper transistor. And this voltage is higher because source is at 0 volts. So this is drain of lower transistors, source of lower transistor. That implies nothing but source of upper transistor and drain of lower transistor are tied together. Okay, and this is Vx is nothing but voltage at this point, which is nothing but voltage at the source of upper transistor or voltage at the drain of lower transistor. That we are going to calculate with the information given. Okay, here the voltage given for the gate of upper transistor is 5 volts. So this is gate terminal for the upper transistor, it is gate terminal for the lower transistor. We know that one, the condition for saturation region, we must know in which region the both transistors are in. So condition for saturation region, condition for saturation is both are NMOS transistors only, so that it must be equal to Vd should be greater than Vg minus Vt. Vt is nothing but threshold voltage, Vg is nothing but gate voltage, Vd is drain voltage. Okay, since the lower transistor is going to be whose gate and drain are going to be shorted, whose gate and drain are shorted, that implies nothing but Vg is equal to Vd. So always Vd is going to be greater than Vg minus Vt. Vg is equal to Vd only, so you can write Vd is greater than Vd minus Vt. So this is always true, because you are subtracting threshold voltage from the Vd and that you are comparing with Vd. So always Vd will be greater by threshold voltage. So whenever drain and gate are going to be shorted for any MOSFET, at that time definitely that transistor will be in saturation region. So that we can say that one, this transistor is in saturation region definitely. So lower transistor region is in saturation because whose gate and drain are going to be shorted. We can say that one, always the condition for saturation region satisfies. So it will be in saturation. So any MOSFET whose gate and drain are shorted, that will be definitely in saturation. Remember that one. Next, what about the upper transistor? In which region it is in? So for upper transistor we must check this condition. For that one you can say Vd is equal to, Vd is nothing but drain voltage of upper transistor, it is connected 6 volts, greater than Vg, gate voltage is connected 5 volts, minus Vt is 1. So that implies nothing but 6 greater than 4. This is also true. So that implies nothing but the upper transistor is also in saturation region. So what we found is nothing but both the transistors are in saturation region. Okay, and K is going to be given 100 microampere per volt square, which is common for both transistors. So both are in saturation region. Assume that one, this is the current flowing through upper transistor. Okay, so upper transistor is IDU and lower transistor is nothing but IDL. So whatever the drain current, it is also flows through this source. Can we say that one, IDU is going to be dividing into IG and IDL, IG into IDL, but IG is always 0 because this position wherever you are getting empty space, so this is going to be called as SiO2 layer, which act as insulator. So no gate current flows, that is nothing but the charge carriers are not going through this silicon dioxide layer, so that there is no closed loop, which always gives Ig is equal to 0. That implies nothing but current flowing through lower transistor is nothing but current flowing through upper transistor. So even though the connection is towards gate but no current flows through gate because gate is insulated by SiO2 layer which acts as insulator which doesn't permit any current. So current flowing through upper transistor is nothing but current flowing through lower transistor, and both the transistors are in saturation, so that we can write the equation for the saturation is K into W by L of upper transistor into VGS minus VT of upper transistor whole square. Okay, next here it is K into W by L of lower transistor into VGS minus VT of lower transistor square, and K value is given, both is going, both for both transistors it is same. So W by L of upper transistor is 4 times of Vg minus Vs minus Vt whole square of upper transistor. Okay, and W by L of lower transistor is 1 into Vg minus Vs minus Vt whole square of lower transistor. Okay, this is of lower transistor. So 4 times of Vg, upper transistor gate voltage is connected at 5 volts minus source voltage of upper transistor. Source voltage of upper transistor is nothing but this point, that itself you can say it as Vx minus Vt is given as 1 volt whole square is equal to 1 into something is that something. So Vg, gate of lower transistor, gate of lower transistor is connected to drain of lower transistor, drain of lower transistor is nothing but Vx. So Vx minus Vs, source of lower transistor is connected to ground, so this will be 0 minus 1 whole square. So 4 times of 5 minus 1 is nothing but 4. Okay, 5 minus 1 is nothing but 4. 4 times of 4 minus Vx whole square is equal to Vx minus 1 whole square. So take square root on both sides, so that this will become 2 times of 4 minus Vx is equal to Vx minus 1. So this is 8 minus 2Vx is equal to Vx minus 1. So if you take 3Vx is equal to 9, and from that one you can say Vx is equal to 3 volts. Okay, you cannot take square root of 4 as minus 2, even though square root of 4 can be either plus 2 or minus 2, but you should consider only plus 2, otherwise Vx will be negative. So for an NMOS transistor, drain voltage cannot be negative, so that you must always consider the positive sign for the square root of 4, so that we have taken it as plus 2. So Vx is equal to 3 volts. The right option for this question is nothing but C. Vx value is nothing but 3 volts. Thank you.